Hi everyone, welcome back to another Planetarium live stream. My name is Jessica. I am the director of the Planetarium, and with me are two, which should be familiar faces if you've seen any of our streams in the past. We've got two of our students with us, and I will let them introduce themselves, starting with Eli, since he is to my left.
Hi, my name is Eli. I'm a physics and astronomy student at UMD.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So tonight we have a new edition of a show we've been doing at the Planetarium, Her-sotry of STEM. We've been doing a version all about spaceflight and the amazing women who helped launch us into space. But tonight, our new version is all about the Her-sotry of Astronomy, and so women who made important discoveries in the field of astronomy, many of which actually helped the names you probably do know make their advancements and don't get talked about enough. So I'm going to turn it over to Lindsay, who is going to tell us all about these amazing women. And if at any time you have any questions, leave them in the comments. Eli will be checking those for us and will let us know whenever you have comments. And if we don't get to them right away, we will take some time at the end and answer those that we didn't get to right away. So take it away, Lindsay.
All right, great. Get started here. Okay, so like Jessica said, today I'm talking about the Her-sotry of Astronomy, so all of the women in the history of astronomy. And my purpose for this presentation is to inform you about as many women as I possibly can. You know, everybody knows about the female scientist Marie Curie, and she was amazing, but there are a lot more female scientists out there that people don't know about because their stories weren't told or got lost to history. So I'm not going to go too into depth about any single one woman in this presentation, but try to get through just a lot and introduce you to a lot of different names. There are over 40 in this presentation, and that's not even all of them. So first, we are starting in the 2nd century BC with Cunitz, and she had such a great knowledge of the moon, and she had such great data about the moon. She was able to predict lunar eclipses, and so people thought she was a sorceress because she had such good data about the moon that she would just like tell them when it was going to go dark because she knew when the lunar eclipses were going to happen, and that's why they thought that she was a sorceress. Hopping up to now, the 4th century AD, ancient Greece, we have Hypatia. She was a professor of astronomy in ancient Greece. She not only taught mathematics and astronomy at a local school, but she also taught public lectures, so the public were able to learn from her expertise as well. In the 10th century, we have Mariam al-Asturlabiyy, and she was Arabic, and she manufactured a lot of astrolabes, and that's the picture on the right there. I couldn't find a picture of her, but these astrolabes were used for navigation and to find stars in the sky and things like that. So you've used for many centuries after this. In the 16th century, we have Sophia Brahe. So you may be more familiar with her brother, Tycho Brahe. He was at the Royal Observatory in Denmark at this time. He is famous for making a lot of astronomical observations. And she assisted her brother with those, and their observations led to a discovery of a supernova. In the 17th century, first we have Marina Cunitz. She authored a book that included new solutions for determining the positions of the planets. The original solution for that was put up by Johannes Kepler. Elisabeth Hevelius. She was known as the mother of moon charts. She and her husband, Johannes Hevelius, cataloged more than 1,500 stars. Into the 18th century now. Nicole-Reine Lepaute is a French astronomer who predicted the return of Halley's Comet, and Halley's Comet is pretty famous because it is visible in our night sky every about 75 years. Marie Jean Amélie Le Français de Lalande, she established a catalog of over 10,000 stars. Caroline Herschel, okay. Caroline Herschel is pretty amazing. You may have heard the last name Herschel before, and that's because her brother William Herschel is famous for discovering the planet Uranus, among other things. And she actually was an assistant for her brother during that time, so she helped him discover Uranus. On her own, though, she did plenty of discoveries. She discovered many comets. And so anytime you see a comet that's named after a Herschel, it's actually named after Caroline Herschel, not William Herschel. She also created a new updated star map, and she was the first woman to get paid to do astronomy. So that's pretty cool. She was in England. All right, hopping up now to the 19th century. Maria Mitchell, she was the first female astronomer in America. She discovered a comet in 1847, and she won a gold medal prize for that from the King of Denmark. Agnes Mary Clerke, her greatest work was a book called The Popular History of Astronomy During the 19th Century. Mary Adela Blagg, she observed the moon and created a list of all of the lunar features she could find. She also created the naming system for naming things on the moon, and we still use that system when we find things on the moon and need to name them. Okay, so now kind of at the end of the 1800s and the beginning of the 1900s, there were many women working at the Harvard Observatory. They were known as Pickering's Harem. So Edward Pickering ran the Harvard Observatory at this time, and all of these women were the human computers. So they did any calculations that needed to be made. They looked at photographic plates and collected data about the things that they would see on the photographic plates. So, but they were never allowed to use any of the telescopes. So the men would get to use the telescopes and get to take pictures of things, and then they would pass everything off to the women, and they would be collecting the data. But they didn't just collect data. Many of them made their own discoveries that were pretty important in astronomy. So we have Antonia Maury. She published an early catalog of stellar spectra. Williamina Fleming, she cataloged thousands of stars and helped create a classification system. She also discovered the Horsehead Nebula, and that is that picture at the bottom of the slide there. Henrietta Leavitt is one of my favorites. So she discovered the Cepheid variable stars and that they could be used to measure distances. So Cepheid variable stars always reach the same magnitude. So you can look at how far away they are and how bright they appear to figure out how far away they are. So anyway, we could measure distances. So this guy you might know, Edwin Hubble, he was trying to figure out if this thing called the Andromeda Nebula was in fact in our own Milky Way galaxy, and our Milky Way galaxy was kind of the entire universe, or if the Andromeda Nebula was actually an entirely separate galaxy and there were many other galaxies outside of the Milky Way besides just our Milky Way galaxy. So he had to find a way to be able to measure all the way to the Andromeda galaxy. And so with this method that Henrietta Leavitt discovered, he was able to do that. And so without her and her discovery about Cepheid variable stars, he would not have been able to measure the distance to the Andromeda Galaxy and make the discoveries about galaxies that he did. Annie Jump Cannon, she did a lot of things also. One of the things that we still use today is the stellar classification system for stars. Cecilia Payne-Gaposhckin discovered the composition of the sun, no big deal. So before this, nobody knew what stars were composed of. We kind of thought that since, the sun and all the planets and everything were all made in the same area of the galaxy, that they were all made out of the same stuff. So we thought that we would see the same elements and things that we see in the Earth in the sun. Well, at this time they were able to take stellar spectra on those photographic plates. And so she was able to look at the spectra of the sun and discover the composition of it, and that it is mostly hydrogen and helium. And that is also the composition of every other star out there.
Wasn't helium unknown before this? Sorry to interrupt.
I think so.
Because I thought it was named helium for Helios' sun, because they saw this unknown thing in the sun. Anyway, sorry. I just always thought that was fun.
Yeah. Muriel Mussel-Seifert, she discovered the Ring Nebula, which is that picture there. And the Ring Nebula is one of my favorite things to look at through a telescope. Going on to the 20th century. So these are now women that were not part of Pickering's Harem or the Harvard Observatory. So we have Elizabeth Alexander. She worked with radar technology during World War II, and that led her to become a pioneer in radio astronomy. Another pioneer in radio astronomy was Ruby Payne-Scott. She was from Australia. She was first interested in radio physics, and then ended up being the first female radio astronomer. And so just like how telescopes collect light waves and we can learn things about the universe by looking at the light in the universe, we can also learn things about, the visible light in the universe. We can also learn things about the universe by looking at the radio waves that are out in the universe. Priscilla Fairfield Bok, she authored papers on star clusters and star magnitudes. That's her and her husband, who is also an astronomer. Ava Einart Rolfs, she made observations of variable stars. Elisabeth Romer, she discovered 2 asteroids and a moon of Jupiter called Themisto. She also collected data about the magnitude of comet nuclei. So the nuclei of the comet is so the comet has like a ball part and then a tail. The center of that ball part is the comet nuclei. Erika Bohm-Vitense, she studied convection in stellar atmospheres. She realized that UV light is the best way to observe the chromosphere of stars. Vera Rubin discovered dark matter. So in galaxies, it was found that based on the distribution of the mass in a galaxy and physics, the speed of the outer parts of the galaxy were not the speed that they should have been based on the distribution of matter throughout the galaxy. So because of that, we think that there's some missing matter throughout the galaxy that accounts for the speed discrepancy of kind of the outer parts of the galaxy. And so we are calling that dark matter. And she was the first person to discover that discrepancy. Carolyn Shoemaker, she discovered a lot of comets, including comet Shoemaker-Levy 9. If you remember back in 1994, there was a comet that struck Jupiter's atmosphere called comet Shoemaker-Levy 9. So that was one of the comets that she discovered. Jocelyn Bell Burnell, she was working for Bell Telephone Laboratories, and they were doing a lot of work with radio waves, and she discovered the first radio pulsars. Maria Antonella Berrucci, she discovered 3 minor planets. Steffi Baum, she helped develop the Hubble Space Telescope, named after Edwin Hubble. Tabitha Boyajian, she discovered Tabby's star, which has a very unusual light curve. And so we haven't seen any other stars with the light curve that Tabby's star has. And so some of it dims and brightens in a strange pattern. And some of the ideas about how that could be happening kind of include like an asteroid belt, but not as evenly distributed as our asteroid belt. Something orbiting around the star that is kind of blocking out things. And another thing that was presented as a possibility is called a Dyson sphere, which is potentially a futuristic structure that would be orbiting around a planet, and people would be living in that. That has since been debunked, but we're still not really sure what is causing the unusual light curve with this particular star. Katie Bowman. So she created an algorithm for imaging black holes that led the team to complete the task. So you may have heard in the last year or so that there was an image of a black hole that was finally taken, of M81. And she was the person that was able to create the algorithm to put all the data together so that we could finally see the images or an image of a black hole. Jessica, you have anything to add?
I'm trying to think. I know you've covered most of the ones that I know and that I can think of. There are a few in there I didn't know about, which is really awesome. And also just sad that I didn't know them. But there's so many amazing people, so many amazing women who's
started out, trying to make a show about the history of astronomy and spaceflight, but ended up finding too many women that I had to make more than one show. And that is still happening. I keep finding more and more women to add to this every single time I do it, which I think is exciting.
Absolutely. Eli, did we have any questions come in?
Nope.
No? All right, well, if you do have any questions, now is a good time to ask them. You can just write them in the comments. And while we wait for that, I guess I will let me switch over. There we go. Just to remind everyone or let you know, if you didn't know about it, that we are doing a giveaway. As you can see here, there was this cute little glittery dinosaur that was taken up to the International Space Station with the Crew Dragon launch that happened a few weeks ago. And we have a few of those, a few of these plush dinosaurs, just like the one taken into space. And we are giving away 2 of them. So if you are interested in entering our giveaway, you can head to the site that is listed there. It's also linked in the video description. But the general idea is we want you to create a mission patch and share your design with us, and you will be entered into a random drawing. And we will be doing that on July 1st during our live stream. So we're super excited. The first ever giveaway that we have done for these adorable little dinos. And I think it's going to be great. I'm really excited to see everyone's mission patch designs. So I'll leave that up for another second, just so you can have that website. It is also linked in the description, and we have a post all about it on our page as well. So
I'd like to add, why these women's names were lost to history in the first place.
Yeah.
And a lot of that was especially the women that were part of Pickering's harem, they found the data and found out the information about the stellar spectra and things like that. But the kind of like the head people of the Harvard Observatory, which were men, took all of the credit for everything that they found. Also, you see a lot of the women have hyphenated names. And like Cecilia Payne-Gaposhckin, she started out just as Cecilia Payne. But when she got married, she didn't want to change to Cecilia Gaposhckin because as Cecilia Payne, she discovered the composition of the sun. And people might not know that Cecilia Payne and Cecilia Gaposhckin are actually the same person.
Which is a pretty common thing, even still today with female scientists, is when they get married, they tend to either keep their last name, at least for academic work, or hyphenate like that. Because
if they publish papers before they get married, people might not know that's the person.
Absolutely.
I actually didn't know that. That's interesting.
Yep. So, anything come in?
Nope.
No? All right. Well, thank you to Lindsay for putting this together. Hopefully you have learned something new and maybe found some new role models or inspiration. I know a lot of my personal female role models are in that presentation, along with the Her-sotry of Spaceflight that Lindsay has done. Let's see. Sorry, let's introduce you to everyone since you're sitting here. Facebook, say hi to Nova, who is not happy to be picked up, but that's what she gets for lying on my keyboard. So next week we have our show schedule posted. On Wednesday, Eli is going to be telling us all about how we know what we know. So things like how do we know how big the Earth is, how fast the speed of light is, these things that tend to just be said as just facts. And so he's going to tell us all about how we figured those things out. And then next Saturday, we're going to be doing a show all about the Northern Lights, tell you some of the mythology behind them, tell you exactly what they are, what causes them, and give you some tips to help you see them for yourself. So with that, I guess we will say goodbye to everyone. Thank you for joining us. All of our past shows are up on our YouTube channel or in the videos on our Facebook page. So feel free to go watch anything that you've missed. And have a great night and a great rest of your weekend. And we will see you next time. Bye.